I would love to actually kick it off with just asking my first question and also giving you guys an opportunity to introduce yourself, while you're answering it. So let's maybe start with the sort of most, wide open question of all. Why are we even talking about Kubernetes at the edge? What is it like? What's so interesting about it? So maybe I'll go in the clockwise order of people I see on screen. So Mikhail, why don't you go first?
Thank you. Mikhail Kozorovitskiy with SUSE, part of the Cloud and Containers Consulting Group. And I think we're here because Kubernetes offers a way to not make quite universal, but to abstract the hardware in a way that is consistent and very flexible. And I think the consistency and the flexibility are what really attracted me. I mean, I had an aha moment when I first deployed the tutorial on Kubernetes.io, and I was like, wow, why is everyone not doing this? And I think that's why we're here.
Awesome. Andrew?
Hi, Andrew Rynhard. I'm the CTO of Talos Systems. Yeah, I think I have to echo the consistency thing. The big thing that I see personally a lot is that people, they're already running Kubernetes in their data centers or somewhere else. And typically where you have an edge deployment, you do also have something in the cloud or on-prem. And so that consistency across all of them, there's one single way to manage your applications and your infrastructure, I think is split tooling, and this split mental model, I think, has a lot of overhead in it that people just simply don't want. And so application delivery, I see people, running Kubernetes at the edge, single node clusters for the sole purpose of it makes it easy to manage my application on it. So that's what I would say.
Makes sense. Vassilis?
Yep. Hi, Vassilis Varveropoulos. I'm an architect with Schlumberger. I'm an architect of one of the 4 divisions, reservoir performance. So for us, it's a bit different. I mean, we are more on the user end of this. And we didn't really start with Kubernetes, right? We didn't really start by saying we're going to put Kubernetes on the edge. We started because we wanted to put more intelligence on the edge, because this is where we generate the data, this is where we have our equipment. And in the process of doing that, we started moving away from the monolithic applications that we use. So, that led us to microservices, naturally. Well, you have to containerize your microservices, you go to Docker containers. And that worked pretty well initially for us. We're using Docker Swarm and, one node, maybe 10 containers. It was okay. As we started scaling up to more nodes and more clusters, we realized that Docker Swarm was just not going to scale at the level which we wanted. Plus, the community, the Kubernetes community, was growing much, much faster than Swarm. So yes, at that point we said, it's time to actually make the jump and start introducing Kubernetes. And it was a challenge, as you would expect.
Interesting. So on that last point, I'm actually curious. It seems like you guys sort of went through this typical, kind of digital transformation journey, right? You started maybe with a monolithic application and then introduced containers. And I'm actually curious, can you maybe recap either specifically on the edge or just Kubernetes in general? What ended up being top 3 of your takeaways, right? It's like if anybody else is going through the same, what would you recommend they do?
In terms of lessons learned?
Yes.
Yeah. So I think the first is, make sure you have the scale to actually justify introducing Kubernetes, right? If you have just a few containers and a single node, low compute node, probably doesn't worth it. If you have the scale in terms of workloads, in terms of a number of nodes, then it starts making sense, introducing it. Now, the other thing is, I would definitely, even though we did it, I would definitely recommend against doing this the first time on the edge. Right? If you're starting with Kubernetes, it is best to be familiar with Kubernetes as a service provided by one of the cloud infrastructures, familiarize with the technology, and then start moving on the edge. Because everything is basically down to the bare metal on the edge, right? So you have to really understand the low level in order to be able to manage it. And the last thing is don't do it on your own. I mean, you have to partner with companies that do this for a living, right? So that you get to focus on the things that matter, not necessarily the infrastructure.
Yeah, no, that's actually a great point, because I think you made this point as well, that Kubernetes community seems to be wonderful, and one of the really cool things about such a vibrant community is that you have a lot of places you can turn for help. So I absolutely would echo that same, and we have vendors, but we also have community members, and it's really amazing to see how quickly Kubernetes has become this sort of phenomenon. But I actually also wanted to play on something that you mentioned, which is scale, right? So scale is definitely important. And come to think of it, I mean, edge may actually give us scale that we haven't even seen in the data center, right? If it all sort of pans out, that may be one of the things that would completely dwarf the data center scale. So my question to Andrew and Michael is, are we ready for that scale? Is Kubernetes ready? Is the Kubernetes community ready for that scale? Do we need to do anything different? If we're talking about that level of scale, what are your thoughts?
Are you talking specifically at the edge now?
Well, again, edge just seems to be a lot of different, nodes, right? Where in a data center, it's sort of like, more smaller number of nodes, and maybe you pack more containers on it. But on the edge, like this explosion of nodes seems to create an opportunity and a challenge, for Kubernetes scalability. At least it seems to me that way.
Yeah, I feel like this Kubernetes constantly needing connectivity is going to be a problem, because I see people wanting to run Kubernetes, say, like in a train that's delivering goods somewhere, but it doesn't have internet necessarily. And if you have your control plane perhaps outside of that because it needs to report in, this intermittent connectivity might become an issue, I would say. That's something
That's a great point. Mikhail, any thoughts on that?
Yeah, so I think we are ready. We're ready to begin, and you have to switch to deployment in a different methodology, right? You have to go to a more GitOps model and a pull model where you have inconsistent connectivities. It would be shameful if I don't plug Fleet here a little bit.
For sure.
SUSE's tool to do that, but Argo, and there are plenty of other tools that allow that, right? So, but the reason why we built Fleet was because of that very reason. Is it just fetches stuff at some point, right, whenever it connects, and so you can take intermittent connectivity, right? And so that's how you solve it. Is you have the edge machine connect and batch data and batch whatever it needs to do when it gets a connection. So, and then hopefully slap some kind of card on it.
Yep, and I guess that intermittent connectivity kind of bites you at every possible place, right? Because it's also logging, telemetry that you need to collect, right? All of it is subject to that intermittent connectivity. So in a data center, we kind of take for granted that I'm running my, Prometheus, and I just get to see everything. On the edge, it may actually be, delayed by days, before I actually get to see it. So any thoughts on observability and how do we actually make Kubernetes more observable so it's more amenable to the edge?
Well, that's a good question. Because a lot of that does depend on having that connectivity. One of the things that we're playing with is, I guess this doesn't necessarily solve it in all cases, but we're looking at WireGuard and having this kind of overlay network, if you will, but for the actual machines themselves, where you can actually extend your cluster out from, say, a bare metal cluster on-prem scenario and have your edge machines just be workers that's all over WireGuard. And in that case, if you have some LTE or 5G connectivity, it may be useful, but otherwise I see a lot of problems. With you just need connectivity. I don't see that. I'd love to hear others though if they have ideas.
It's really what I'm always wishing for, right? Because it's really the obvious solution, right? Just make your connectivity more reliable. Come on, I mean, these days I have reliable connectivity. Satellite, cellular, it's all over the place. Reality is that you don't, and you think you do, and you think you've taken every precaution to have it and have redundancy and backups. something will still break, because you're in the edge, you're operating in environments that are unstable by definition, right? It's not your data center, with air conditioning, people right next to the equipment. With the observability and the connectivity, I want to make one comment in that when we talk about scale, at least in the cases in which I'm involved, it's not always scale in terms of horizontally scaling the cluster, right? It's not adding more nodes. It's the number of clusters that scale.
Exactly.
The clusters are relatively small. At least for us, they tend to be 1 to 3 nodes. The observability that you mentioned becomes exponentially more difficult to manage, because now you have to gather logs from 1,000 clusters. And with intermittent connectivity, it becomes more difficult. So, I don't have a silver bullet here, but the solution, at least that we see right now for us, is to have basically logs and observability on the edge. So you design it to be offline. And then whenever you have connectivity, which may be very intermittent, you upload perhaps a digest of those logs into some sort of a fleet management infrastructure. And that will give you enough observability to debug when something goes wrong.
I like what you said. Sorry, Mikhail, I just want to point that out. Vassili, how you guys said you guys are designing it with this. And I think that we need to think this through with a lot of the products that we're doing. Have this use case in mind as we design. Kubernetes obviously didn't, but hopefully this is a feature that can come to it in the future.
Absolutely. And I actually wanted to pick on something, Vassilis, that you mentioned, which is I see it a lot, that the scalability is in terms of the number of clusters, right? And the clusters themselves tend to be small. So my question is actually for Mikhail. I know you guys have this product, called Rynhard, which seems to be uniquely suited to help manage, great number of clusters. And I'm actually curious. Are we at a point where, in order to actually use Kubernetes effectively with a high number of clusters, you would always have to use a tool like that? Or does Kubernetes itself have any kind of, solution maybe in the making to help with this challenge of not just having, a large cluster, but having a great number of clusters themselves in your enterprise?
So if you're pushing me to a Kubernetes core product that I'm not aware of, I apologize. But as far as, is Rancher ready for that? I think Rancher itself was built to handle a couple thousand clusters. It was not, originally intended to handle millions of clusters, which is why with Rancher 2.5, we moved to that fleet deployment system that I mentioned earlier to allow it to handle downstream clusters. But right now, if you want the kind of information that you can get out of Rancher for a downstream cluster, you can't do that, with just fleet, because just by itself, it doesn't ship logs, all the things that we just mentioned. It doesn't ship logs. It doesn't ship monitoring data. However, I guess that's the next step, is building the tools around that, and then supporting that hybrid model of connectivity. And I don't think we're 100% of the way there yet, but I know we're working on it, because I talk, and actually Keith is on a different session, at the conference. But his team is driving kind of that convergence of how do we get all this data that we want and get it from the edge where we have all the challenges we just talked about. So. So for now, I would say we're ready to start.
Awesome. No, that's actually what we all want to hear, because I think, Edge is so new, right? And I think you're exactly right. We're ready to start, but there's such a long road ahead of us, which actually kind of brings me to my next question. I've seen it a lot of times in technology where a piece of technology would come, it would address a particular use case really, really well, and then people would try to stretch it into all sorts of different use cases. We've all seen it. We've been in technology for a long time, right? And typically what happens then, it's either that technology gets bifurcated, right? And now you kind of have two copies, one, for use case A and one for use case B, or in very rare cases, like, I don't know, Linux kernel, maybe one of the few examples, people actually manage to pull it together and say, like, no, this is the piece of code, this is the software that will run on like really small things and really big things at the same time. We're not bifurcating it. So what's your prediction? Do you see Kubernetes bifurcating between sort of the data center and the edge, or do you think the community will keep it together? Just for all of you.
I'm personally hoping we keep it together. I'm a big fan of that. I think we've long been plagued with this bifurcating in many different ways. Look at Linux itself. if you've ever built, Linux from scratch, you'll see really the difference between different distros or the versions of the kernels and the package manager that they use for the most part, and maybe a couple other philosophies like rolling updates or LTS or whatever. I don't want to see that for Kubernetes personally. I would love to see Kubernetes just be Kubernetes. Vanilla Kubernetes be enough for everybody. And let's pull together. It's an open source project. There's no reason why we shouldn't be able to do this. Just make your commits upstream. That would be my opinion.
I completely agree with that. Yeah. Oh, sorry.
So I disagree a little bit.
Now we're getting somewhere.
we have a couple different distributions for Kubernetes, and I think there's room in the community, just like in Linux, for there to be other versions. For the very reason that you mentioned, right? The edge case specifically is very different than the data center edge. You have more power, more resource constraints on the edge than you do in the data center, and that's why K3S was a thing, right? It was a side project by one of our co-founders at Rancher, who wanted to build a solution that worked on the edge, but vanilla Kubernetes was not there, right? Because of these other issues. So, and it just so happened everyone else wanted that too. So I think experience and the market has proven that there's a necessity for that need to be filled. And if we can fill it with an API that's compatible, and we think of K3S as a distribution, not as a fork of Kubernetes, right? To maintain that central API so that you can just as easily move products from vanilla to K3S, right? Now, underneath, the setup is a little different, right? We don't package all the cloud components that, and I think Kubernetes core now is moving toward, to move that out of the mainline. And, was that driven by K3S? I don't know, but I think certainly the existence of K3S showed that was a possibility and that was a need, right? It addressed. So I think we're going to keep it together as far as the API goes, but as far as distributions, no, we're going to proliferate just like Linux because everybody's got different needs.
I think you both have good points, but if I can add a bit from a user's point of view, for us, what is important is that we don't end up with two incompatible environments, right? But part of the benefit of going with Kubernetes is that we can, design applications to be Kubernetes native, deploy them on the cloud, deploy them on the edge, distribute them between them, take experts, from cloud native stuff and move them more to edge development without having to retrain them. So it is important that we keep, at least from an application developer's point of view, we keep it the same, right? So API standards, all of those things are critical. I would not say that we are yet where the Linux kernel is, but there is a risk we might, right? If we continue forking with many, many different flavors. So I think for now, we don't see a major issue, but you never know how far it can go.
No, that's a great point. Actually, wanted to double click into something that I think Mikhail said, which is I actually fully agree, regardless of how we solve it, that edge brings a lot of different challenges to run Kubernetes. And one intermittent connectivity we already talked about. But what do you guys see as sort of one of the biggest kind of like gotchas for Kubernetes to work through? When it comes to full edge deployment, like anything in particular that you kind of like, well, that just doesn't exist in a data center. So like, therefore, Kubernetes is not ready for it, for all of you.
I mean, first of all, I think if I would be running Kubernetes in a data center, I would most likely be running it as a PaaS, right? As a service from the cloud provider. So I would not really have to worry about managing the control plane, setting it up, and all of that stuff. In the edge, you cannot, right? In the edge, you own everything from the bare metal, the hypervisor, the operating system, and then the Kubernetes distribution on top of it. So I think right now the challenge is kind of keeping it all together, managing it, making sure that compatible versions, that you're patching everything. And that's a significant overhead from a user's point of view that I probably don't want to deal with. I'd rather work with my applications, not the underlying infrastructure.
Yeah, I think I'd have to add to that. The maintenance to me sounds a little scary at the edge for Kubernetes. There's so much that can go wrong. And it's not like the data center where you have IPMI or some console, some remote access where if and when things go bad, you can recover. It's not that simple in the edge case, right? So I don't necessarily think this is something Kubernetes can solve. I mean, I'm probably coming from a little bit of a different angle here, building an operating system for Kubernetes. So I'd say maintenance is kind of scary at the edge. Better tooling for upgrading Kubernetes, for example, because there are cases where they deprecate APIs, internal checks, just refusing to upgrade sounds like a really cool thing. Things like that. And I'd also say, my perspective in particular is really just around hardware and just all the challenges that really come with running the same OS. I mean, to, Vassilis, what he's talking about, this idea of consistency. I want to run the same thing everywhere so that it's less moving parts. But I think the edge hardware makes that a little hard, right? Because you have to have, in most cases, modified kernels to be able to run on a Raspberry Pi. It's not real. Well, I can't say real Ubuntu. It's not the Ubuntu that you would throw in your data center, right? It's slightly different. And so to me, those little inconsistencies, I think those kind of scare me a little bit at the edge.
So if I may generalize that point, I think, or more specifically, I guess, is ARM. The problem is ARM versions of things. Everything that I want to use is not available in ARM. We have Rancher for ARM, but our monitoring currently does not deploy to ARM. So also, the load on our monitoring, it takes extra capacity. So capacity and ARM, I think, are two impediments. But I think ARM is trying to do things on that route. And with Apple, coming out with the M1 laptops, now developers can build locally for ARM. And that, I think that's going to make a little bit of a change. So architecture difference, processing speed, those are, processing and memory, but mostly processing, right? And a Raspberry Pi has a good bit of power, but, and it's consistent with other low power edge devices. But that's just a lot less capacity than you run in a data center. So the overhead that you would want, to do the observability things, so you could monitor the same way, those take a significant chunk of processing power. So I think, getting that minimized, or finding a more efficient way to do that will be huge, to really have a robust edge solution built on Kubernetes.
Agreed. I think, hardware is a big challenge. And, you mentioned ARM, which is definitely a sore point for me as well. And, let's not forget that RISC-V is coming, right? There's all this excitement about RISC-V. So we have yet another whole chunk of ecosystem to worry about, right? Pretty soon. So good news is, I guess Go is available. So sky is the limit. But hardware on the edge is super scary. Scary and exciting at the same time, but I think, that's to me one of the big areas where, something needs to happen. And to Andrew, to your point, I think actually to some extent to Vassilis' point, I think, on the edge, it is especially important for us to kind of compress the stack just down to the components we need. So, the users don't have to worry about an operating system versus, Kubernetes versus some kind of infrastructure as code deployment system. So, Andrew, I know that you guys are working on this, operating system yourself. So do you see it as sort of bridging that gap? Do you see it as the only piece of software that will ever be needed between the hardware and the Kubernetes itself? How do you see it?
Personally, I see nodes and the operating system and all the tender love and care that we have to give them as an impediment to our ultimate goal, which is to run distributed software. And if I have to worry about each and every individual node, and again, to Vassilis' point about, most of the time it is a single cluster with maybe a handful of nodes. So it's not quite as out of hand as, say, in the data center. But the more you have to worry about each and every single node, that's just that much more overhead, all the problems. So I personally see Kubernetes as an opportunity for us to get a distributed computer of sorts, right? Like really, all we should really see the nodes as is more compute to a larger system. And if I have to worry about the individual nodes, then that's not really living up to the promise of Kubernetes, in my opinion. So I think we need to design systems, like you said, that are purpose-built for running Kubernetes, where we don't care about what's on the operating system anymore, because Kubernetes is the single API that we need, and that's the end all right there.
Yeah. There is one more complexity with this, right? When you are operating on the edge, you typically don't treat your device as just compute and memory, right? It interfaces with equipment. It interfaces with even people, right? Somebody may using a user interface that is exposed by that device. So those are typically use cases that Kubernetes doesn't always take as a top concern, right? I mean, you have specific, and you have a GPU, memory, CPU, you abstract that. But how do you abstract the PCI right, that you're using to interface with your equipment? You can, it is possible, but I think there is a lot of room for improvement to hide this more from the applications and make it easier to use.
So I'm going to be a contrarian here. I'm sorry, but so I think we're talking about two different use cases. And if, to Vassilis' point, if you treat, each edge device represents a real problem, an instance of something in the real world doing something. You can't treat it like cattle, because that's important. That's an important device for somebody. So I think that, a few companies ago, I was talking to one of our data architects, and they were talking about designing this edge mesh. And I was like, well, you could do it in Kubernetes, but why, right? Each of these devices is like, there's a need. There's just a lot of them, right? A telecom with 10,000 towers, or a oil company with 10,000 wells. Either way, each of those things is a money-making or a money-costing real piece of infrastructure. So I'd say we need to focus on the opposite. How do we get more, how do we make that more unique so we can, get the right information, not be overwhelmed with sensors and alerts, but get the feedback, that we need to know all the parts of the machine, right? And I mean, in a way, we do agree on that, 100% agree on that part, where there should be one way to do that, one API to rule them all, as we've said at SUSE, and I think you've said something similar. But
no, that actually makes perfect sense to me, and that kind of dovetails into a question that I really wanted to ask all of you guys, because you've been doing Kubernetes for quite some time, right? And so far, we've only talked about kind of like nice things, things that sort of work. I actually would like to ask you just name a few things that completely didn't work. What was it that you tried, or maybe a customer of yours tried, that maybe even at the time sounded like a good idea, but in the end was like, well, what, Kubernetes is just not designed for it. Like, you shouldn't be doing this. Like, Kubernetes is awesome, but it's not really all things to all people. So like a couple of examples of what went wrong.
I can start. So it was actually, I can give you one example, but I will not blame it on Kubernetes.
Okay.
So one of the reasons we picked Kubernetes, or at least we went with microservices, Kubernetes, and the like, is to accelerate the deployment of our applications to the devices, right? The continuous deployment and continuous delivery dream. And I think that you can achieve much easier when you are in a cloud infrastructure. Now on the edge, we started running into issues, right? We wanted to start deploying, upgrading specific microservices every week, right? But sometimes even pulling an image, because your network connectivity is very, very intermittent, it could take hours. So a lot of the things that you kind of expected you're gonna get by switching to Kubernetes didn't really pan out, or they were more challenging than we had anticipated.
Yeah, I think I want to touch a little bit on just this theme we keep having, scale. I think scale, you always have to consider, do you really need Kubernetes for your single application that's running on one node? I think when you try to use Kubernetes in places where you don't need it. It just becomes more of a nuisance, if anything. Sure, you want to plan for scalability in the future, but as I'm going through this business process as a co-founder of a company, sometimes it's just more important to get it done, you know?
Mm-hmm.
And so I would encourage people to ask themselves if they really need it at this point, because start with containerizing it. Start with that. And if you can containerize it, you can move to Kubernetes more or less easy enough, because typically the challenges are taking this monolithic Java application and turning it into microservices and running it in a bunch of different containers.
Yeah, throwing the entire monolith into Kubernetes is not going to fix anything.
Have you had that done? Have you had that done? I'm actually
curious. Absolutely.
Yeah.
500 gigabyte files, like images, like, yeah, absolutely. I have seen all sorts of crazy things. But Kubernetes was never, I mean, at the edge where there are resource constraints, that's where I see Kubernetes being a cause of the problem. The rest of the issues were all implementation problems of like not understanding, not planning, or do plan and still, have issues with execution, right? So there are a lot more human problems, or like, yeah, the majority that I've seen are human problems. They're, you can't really fix that without fixing the humans. And and that comes from education.
Or organizations, for that matter. I mean, a lot of it is organizational problems, right? As at least I see it in my company as well. So let me actually switch gears a little bit and kind of like, maybe talk about what could have been, right? Because a couple of things that I've been mulling over, I'm like, well, what's the good example of the edge? Because we keep talking about the edge computing as this, new thing, and it sort of is. But I'm like, well, botnets have been on the edge, for as long as we can remember, right? They are probably the proto-edge, and they've been pretty successful. So my question to you guys, are botnet authors switching to Kubernetes APIs anytime soon? Like, what do you think? I mean, or...
No, absolutely not. Because now Kubernetes API and Kubernetes should learn from botnets, because botnets, for everything you just said, botnets are an example of a decentralized system that works well, has command and control, but basically like, are edge driven. It's kind of like the way Fleet was designed. It's edge driven. So by the way, you can use Fleet for botnets if not that you should, but not trying to build that kind of customer base. But the problem is that Kubernetes was not built to be stealthy, right? It's meant to encompass that device and take over all its functions, and in a perfect world, allow you to do system upgrades right through that same API. So whereas the botnet was, meant to be a clandestine thing, now the technology and the way that it works, we definitely should copy and emulate, because it's proven to be effective. But it doesn't work the other way just because Kubernetes is a big thing. Like it's meant now, someone might design after this a stealthy version of Kubernetes that
would have been awesome
itself on your system, and then there's no reason why they couldn't run their botnets off Kubernetes. But I think the intricacies of that are like a little bit more problematic than that, technically.
Awesome. All right. So next question. We actually have about 5 minutes left. So my next question is sort of, again, kind of what could have been, in a sense that, I'm sure you guys are in the same boat, but, we all started long time ago, right, in this distributed compute industry. And we probably all remember that, Eucalyptus came and went. Then there was the whole OpenStack thing that came in. I mean, not went, but like it's not really a hot new thing anymore, right? So what's your take? Do you think, 5 years from now, we will be sitting in a conference like that talking about something completely new? Or do you think that Kubernetes is here to stay for much longer than all of the previous technologies?
Well, I hope it's here for much longer than these previous technologies. But you just never really know. I mean, there's so many smart people out there that are figuring out really cool things. I think there's a lot of lessons learned from Kubernetes that will stick around. All of the patterns, the operator controller pattern, I think a lot of those things will stick around. So if we do see something in the future, it will look and feel a lot like Kubernetes, maybe with some implementation details that could be arguably better.
Okay.
I think we'll see Kubernetes because of its extensibility, because of the ecosystem built a lot like Linux. I think it will have the same staying power as Linux, because no one is talking about, well, okay, some people are talking about replacing Linux, but we've made Linux do some pretty awesome things, like everything from electric cars, to tiny edge devices. So, and to satellites and all that stuff. But so I think Kubernetes will adapt, it will grow, and will further divide, maybe not from an API standpoint. I think, there is, all of us as technologists, I think, see the value of not messing that up. Like, because of its extensibility, we can build our own toys and tools on top of that in a way that doesn't destroy the framework, but builds in whatever functionality we need. And I think that shouldn't be underestimated. Like, it is, to me, I think it is a generationally revolutionary tool that will be here in probably, definitely in 5 years, probably in 10. I can't see beyond that. I can't even see
awesome.
10 years. I'm just
that's actually an awesome point. I fully agree with that. Vassilis, what's your take as a customer?
I think it's still growing. I don't see it kind of going away anytime soon. At the same time, I am looking forward to change, right? I'm looking forward to it evolving and improving, or even changing completely. I'm hoping that will happen in a way that is not going to force us to completely revamp what we've done, right? I think we've learned the lessons of the past and try to keep things kind of making the transition easier for the users. As long as we do that and have those technologies evolve even beyond Kubernetes to something else, I think we should be open and ready for this. And I think that's why it's important to be embracing some of the open source community and technologies, because it makes it easier to follow and adapt.
Exactly right. All right. Thank you so much, guys. I mean, it's been amazing. I actually had tons of fun asking the questions and, just listening to you. We've got about 3 minutes left, so I was just going to say that, why don't you just go around, with any kind of closing thoughts, for all of our listeners. And I'll just shut up from now on, and just wanted to thank you once again. So, Mikhail, you go first.
Yeah. Roman, thanks for having us, and ZEDEDA. This has been awesome. My closing thoughts are that Kubernetes is going to stay at the edge. ARM will solve their problems. We're going to continue to see an expansion of this technology and into every crevice down to our watches. And, I think that's the future.
Sign me up. Andrew.
Yeah, a lot of fun. Thank you for having me. Mikhail, thank you for differing opinions. I learned a lot, actually. And I may question some of my own ways. Hopefully we could chat about different things in the future. And this was a lot of fun. Thank you.
Looking forward to it.
Thank you. Same for me. It was very interesting to talk about something that we are all very passionate about. I think for me, I'm really looking forward to seeing more and more companies and players kind of growing and entering this market, like all of yours, because it does help us to actually do this faster and do this better, right? Rather than everybody doing it on their own.
All right, awesome. Once again, thank you so much, and that's a wrap.
Thank you.
Thank you.
Thanks.